Jaron, I did have a couple of requests from something that you mentioned a few weeks ago. I don't know if you want to address that today or if you want to wait till next week or whatever, but people were asking about the comment that you made about what you had figured out about the southern flight routes and asked me to ask you about it.
I could do a quick run, 5-minute run over, just so that people, I haven't had a chance to make a video yet. I want to, but there's more research to be done. But basically, just once you figure out how the jet streams work, and then I had to figure out, you had brought up that Earth.News School earlier.
Mm-hmm.
And if you go to that, actually here I can share my screen real quick. I'll show it.
Okay, let me stop sharing mine and we'll go to yours.
Okay, tell me when you can see my screen.
Okay, yep. You're on.
Okay, so looking at this here, bring this back up. So I've already done the AE projection, put it on wind, and these HPA are the Pascal. This is your pressure basically, and HPA is 100 times the PA, which is usually the number that you get. But you can just go through each of these and figure out where that is in the so-called height. If you're talking about a 40,000 foot plane, or you're talking about whatever. So getting up to 250, and I want to see if I have that written down, what 250 is, because you have each one represents, a certain height, and so is temperature, right? So once I figured out that, let's see, 30,000 feet is about 300 HPA. So, you can go about 250, which will give us, around that area. 40,000 feet usually comes in at 187 HPA, so that'll be in between 70 and 250. But you can see these are the winds that are being blown, and you see this path here, which would be somebody going from New Zealand to South America. And if you look at these winds, you can see how fast they're moving. That's 180 kilometers per hour. This is 168. You can kind of follow this path, 176, 188. And so that right there is 219. So that's about, 150 miles per hour? Don't know the
right.
So once you can add that to the speed of the plane. So by going to, this is my flight radar, which I play with all the time. So if you're looking with like Auckland to Santiago, so they're going this way, you can, if you had an account here, you can follow this plane and see what the ground speed is. You'll see it's at 544, 577, 601, 616. Now this will eventually just disappear because the plane gets far enough away from the land. You can zoom in here and watch this plane. It will disappear right when it gets to here, gone, and reappears all the way over at the other side. So we don't know what it's doing in between those two locations, but we do see that it's getting up past 600 miles per hour. The GPS altitude is showing well above 40,000 feet, and then it just drops back in, coming usually at, let's see what it does when it drops in. So it comes back at 616. So now what happened in between these two locations, especially if you take that 616 and you can add whatever the miles per hour of the wind is. So if you take 616 and add 150, then you're already looking at 760 or 770 miles per hour. Well, then when you figure out that amount of miles per hour over that distance, which they claim is 6,005 miles, but you can take that speed over the actual flight time, which this one here shows actual flight time 1048. You can come down here and see that usually it's about 1039, 1030, 1044, 1057, 1046. So you can just multiply it by that, and you can get upwards of 9,000 or 10,000 miles. So all of a sudden now we can travel 9,000 or 10,000 miles instead of the 6,000 needed. So that was easy for me to see that when you look at a Gleason's map, which, I'm not in full agreement with the Gleason's map because I don't know what the outside edge would look like. I don't know if it's the way it's presented to us, but certainly I think it's highly possible that the continents are laid out in the way that the Gleason's map shows. So when you draw your line from Santiago to Auckland, that it looks to be about, definitely less than half of the equator, which the equator would be, half the equator would be 12,500 miles. So I'm easily able to show 9,000 or 10,000 miles is not out of the question for this distance here, which means simply by getting up in the winds aloft, you're fine. Now, going the other way, if you're going Santiago to Auckland, that changes a little bit, because now if you go back to your, winds here, you can see that, come back. You can see that there really isn't any wind stream that anybody can get in going this way. And so that would cause the time to change drastically, especially since you can't add any winds. If the plane's going 650 or so, well, you're going 650, but you'd actually have wind in your face, which is going to cause you to go even less. And then you can't get that 9,000 or 10,000 miles. So that's where I was having trouble. But you can actually change your height, go towards 70. And here's something I found out too, that the air pressure can change with your temperature. So one thing I found, and Bob, I don't know if you know this to be true, that with each 10,000 feet, with each 1,000 feet in altitude, that the temperature goes down about 5 degrees Fahrenheit. Have you seen that before?
Yes. Yeah.
Okay. So, if we were to say 50,000 feet, if we were going to put a plane at 50,000 feet, that would mean 50 times 5 is 250 degrees Fahrenheit less than when you left. So let's say it's a 90-degree day. So now you're talking about 250 less than that. So let's say 160, negative 160. So you put in negative 160 as your temperature and 50,000 feet and calculate that. Well, it comes down to 1,154 PAs, which again is HPAs would be only 115. Or would it be 11? Might be 11. Might even be lower than that. So when you get up to this, going back with your HPA on your, let me see where my map is. So then you can get down to this 10 HPA. And when you get up there, now all of a sudden your winds change. And you have winds going the opposite direction, where you can have somebody catch this jet stream moving this way. So that made me say, okay, well, the reason why planes this flight does take a lot longer. Am I doing that right? Let me make sure I'm going the right way. Santiago to Auckland Santiago to Auckland takes 12 and a half hours, whereas Auckland to Santiago only takes 10 and a half hours. So you're talking about a 2-hour difference. Well, as you can see, we don't have as much wind as our back. We have 65, 61, 94. So there's not a huge jet stream going this way, but it is, so 94 kilometers per hour, let's say that's 60 miles per hour. But then you can add that to the 625 or so, and you can get up closer to 700 miles per hour. And then you have to look at that plane, and can that plane actually go faster than we even think? And the answer to that is clearly yes. Most of the time the Mach 1 is the what they try and stay under. And, it's highly possible that they're going up this high, because that's only, what did we put, 50,000? That's 50,000. And if the plane is anywhere near special, and if we go back here and see what plane we're looking at, this Boeing 787 Dreamliner, and we'll put that in here to get a Wikipedia up. But when you look at this actual plane, it describes it as being a special plane that needed special permission because it's different. It's, see here, where we go here, it's got lithium ion batteries, which is different than most planes. And then down here, they've got different rules, like there's a certain amount of time that has to pass before a plane behind you takes off. Usually a plane takes off, and I think it's like 90 seconds or something. But whatever it is, this plane has an additional amount that you have to wait. So most planes are 90 seconds. This plane's like 3 minutes. And they also describe it as being almost completely and totally automated. It's all done through computers. Basically, the pilots can play cards. And there was an interesting interview with Buzz Aldrin, and they were asking him about whether he likes to fly or not. And he says, not anymore. He says, I go up in the cockpit because I used to like to, they would let me fly the plane, because I'm a former pilot. But he says, nowadays I go up there and those guys are playing cards, that they're not even flying the planes anymore. And he said, that's a problem because we don't have pilots that actually know how to fly. And that's sad to hear. But at the same time, how is it hard for somebody to imagine that those planes would be able to go different speeds? And people think that you'd be able to tell the difference, but really when you're talking about going 650 versus say 750, Bob, as a pilot, you would say there's probably no way to tell that, not when you're up that high.
No, not at all.
Right. And so do these guys know exactly what's going on and how they're traveling? And and I get a little bit confused when looking at Looking at these, I have a true airspeed versus ground speed versus indicated airspeed. And I've kind of gotten a grasp of it, not enough to do a video yet, because basically ground speed, Bob, is how the plane is moving relative to the ground, correct?
Yes, along the
Right.
ground, and that's the with the wind behind it. So you can be going considerably faster. You can go Mach 1 ground speed, if you have a significant tailwind. And also another thing that I wanted to mention too is when you go from standard speed aircraft to the ones that are going supersonic, the traditional measure or the traditional instrument, excuse me, for measuring the speed, which is called a pitot tube, is no longer effective, and it requires a different piece of equipment. And that could also be another thing that may or may not be fooling the pilots. And of course, that goes back to whether or not they're even in on it, on those special flights. But that is something that would be different. You're not going to get an indicated airspeed of, Mach 1 with a standard pitot tube.
Right. And I've actually watched these winds before too and noticed that they change on a day-to-day basis, meaning like today I don't see any red jet stream going towards New Zealand from Santiago. Now, I haven't had a chance yet. And what I wanted to do was to track it and see if exactly it correlates with it. Because if you look back here, and I have an account at this site called Flight Radar, where I can look at up to 180 days in history or something. But I can go through and see the amount of time each of these flights took. And you'll notice that sometimes, for instance here, this flight took 12 hours, 3 minutes, whereas the next one took 10:54, 10:50. Well, this is because of the winds, that if the winds are not conducive to a quick travel, well, here's one 11:34. But you'll see there's a vast amount of difference in, say, this one down here said 9 something. Is that what I saw? Yeah, so this one here, Auckland to Santiago, took 9 hours and 46 minutes, whereas up here we saw one that took 12 hours. So there's a huge difference, and that would be the result of varying winds. And yeah, I mean, one thing that I wasn't doing was changing the temperature. So basically, when you get to this page, let me see if I refresh this page. When you get to this page, it's stuck at 15 degrees Celsius, and they call it a default. But if you put in, 50,000, you put in 50,000 feet, altitude here, and then calculate that. But I didn't change. Whoops.
What
did that do? Okay, come back. 15,000 or 50,000. So if you put in that and you don't change the temperature, well, it drastically. Okay, so see the difference here. This is 11,597. But by putting in the temperature that we came up with, which was negative 160, and that's going to change this by almost tenfold. So then I was able to see. Okay, I see what I'm doing. I'm not getting the true height, because before I was kind of looking at this and seeing only about 250, and then I was trying to go back and forth between the 70. But you'll see these things, how differently the winds move. And as you go this way, you're getting close to the surface. So here's your surface winds, which aren't much. And then from there, you can go to 1,000, which is the HPA. It doesn't seem to change much. You get up a little bit higher, not changing much. But now once you get up to where the planes are, 500, 250, or 70, now you'll see that there's huge jet streams. And that's why planes go up there. And look how fast this is going, almost 200 kilometers an hour. And so I just think they're simply catching these jet streams, flying right through to Santiago. And that's why, again, we're not really seeing any red movement the other way. You'll see here, if you had to go this way at this height, which probably puts you about 30,000 feet, you're not going to make it. You're just not going to get there, but not in the time that you need to do it. But if you change this to 70 or 10, and that's how I'm sure they base their height, is that if you don't have any winds that can get you there at 70, then they'll move you up again. Now we've got winds going this way. So, and even 10 HPA is not out of the question when you look at the temperature, and then you look at about 45,000 to 50,000 feet, that puts you at about that 10 HPA, which can easily get you there. So that was basically all the video I was going to do, was kind of explaining that I don't think of this anymore as a make or break as far as the flat earth goes. Once I realized that you have jet streams at different levels, and that there's definitely jet streams going towards New Zealand, and definitely jet streams coming towards South America, just depending on where you put the plane. Then from there,
Right.
as long as the additional airspeed can get you that distance, and again, we just looked at 12 hours, right? So if you're looking at 12 hours and you know that that plane can go anywhere from 650, 750 I mean, even 700 times 12? Let's see, 700.
7,000, 7140. Or,
84.
oh God, well, I was off.
But,
All right.
then you can start to see, I mean, yeah, they say that the distance is 6,000 miles. And so for us, we don't know what that distance is. But, once you realize that they could easily go 8,400 miles in the same amount of time, in the same speed aircraft that they're telling us they're in, there's not even any fabrication needed. It just is what it is. So to me, that's when I start to, and like I said, what I really want to do is check. For instance, if I check today and see, I can go here and watch today's flight, which is supposed to leave later, and see if this correlates, meaning, if the winds are slow, am I seeing the plane come in? And I'm assuming that would be the case anyway, right? That, that's what's causing those planes to such drastically have different flight times. What else would explain going from a 9-hour flight to a 12-hour flight? It's going to be the winds. So, I mean, if that kind of explains it a little bit. Now, Bob, what would be the difference between when it says calibrated altitude versus GPS altitude?
Well, the calibrated altitude would be what you are receiving off of your altimeter, which works on a barometric type of pressure, versus the GPS, which would be, a sort of triangulation system, from the ground or balloons or however they're doing that. Two different things. But basically what I'm seeing you saying here, and I agree with this, because if you remember, I don't know, a couple months back when I was looking at these winds aloft for possible explanations, I was seeing that it was not out of the question to get winds aloft going as high as 400 miles an hour. Of course, that is far from a consistent thing, but it is definitely something that's registered. So when you take that into consideration, and what I was not looking at was some of the different temperatures and altitudes that you're looking at. I never even considered that. But so what you're saying here then is that if we take those into considerations, and at different flight levels you have these dramatically different speeds of winds aloft, and you combine that possibly with the continents being laid out just a little bit different than what we've been told, all of a sudden the realm of this distance from Sydney to Santiago, making it there in these, in the stated times, are not out of the question. And as you just showed, it is, they don't always make that schedule. And of course, that tells you right there that they're depending largely on these gigantic, winds aloft figures.
Yeah, their times are way off too, usually, versus expected. They can be plus or minus, 2 hours. And then also when we saw Max Egan basically say that he got, about 3/4 of the way, and from the rest of the way, his compass showed southwest, which doesn't match at all what the plane is showing, but does match some of the winds aloft that I was seeing. In fact, I was kind of upset when I looked at this today to not see it today, because this, you can't go back in time. But the other day, there was a red jet stream coming out of here at the when I was at 70, which is only 40,000 feet. There was a red one that was coming out going this way, and it would kind of come up here and then rope down here. And I said, well, this is perfect, because they would just need to fly out of here, catch this red jet stream. It would take them up here, and then for the rest of the the final quarter of the flight would be going southwest per the compass. Now today, that would be weird if I saw somebody flying here to here today, showing them going southwest, because that would tell me here that they didn't catch any kind of a jet stream. But you would have to know the exact height of the plane, and that's where it just gets questionable. But like you said, there's definitely ways it can be done. It's not as simple as, oh, it's not possible. And for instance, like these winds here, we're talking about being 50,000 feet. So who's testing that? Are these that we're seeing on here, are they exactly perfect? Does that mean that there absolutely is no different jet stream going up higher? We don't know that. We can postulate, but you figure it's probably pretty close, that I would guess that, planes would use this. But again, look at here, maybe they fly up here, get into this jet stream, and then they would be going southwest when they come out, because here they really wouldn't. If they followed this jet stream today, they would be coming this way towards the end. Well, this still would be southwest. Even here, right? That's going to be southwest on the compass. So yeah, I mean, that even makes sense then too, that even if they're taking this outer edge, then maybe they would be going southwest as well. So it just no longer is a
Well,
is a
and think of it this way too, though. They could be flying sort of like a chord of that arc. So instead of going due west, which would be sort of the perfect curve as those winds are doing, if you just do a straight line path, that would sort of create a chord between the two inside parts of the arc, and so they would be coming out sort of southwest on the other end of it. I see exactly how that could happen.
right thing
They'd
like
be
this.
taking a shortcut. Yeah, exactly. Yep.
Yeah, so I mean, and they change drastically, like I said. So if somebody, this is a free site you can go to and just check it every day, and change your HPA, which this is going to be adjusted. It doesn't tell you that, it just gives you height per pressure, but you can figure out which pressure is each one. This is a air pressure altitude site where you can go to, and I always go calculate air pressure at altitude just to figure out, if they're at 30,000 feet, which is what most planes are at, which then you'd be talking about 30 times 5 is 150 degrees Fahrenheit. So on an 80-degree day, minus 150 is going to put you at what, negative 70. So now we can go negative 70 Fahrenheit and then calculate that out. So you got 100 or 18,000, and again that's PA. So HPA you have to reduce that, which would be 187. Did I get that right? Yeah, 187. So then you're looking in between these two, which we can't even see. But if the winds change this drastically, see how we've got these winds coming so strongly here, but then here it's different. So that tells me that the layers between these all are different as well. So they might just be able to find different levels that the plane would fly at. Again, we can't see them all. I'm only able to see 250 or 70. There's a lot of layers in between there that maybe they can get at 41, 44, 45, 50,000 feet. Who knows what they're at, but I'm sure that there's jet streams that they can easily figure out and get there. And again, there is some flights that have taken 14 hours I've seen, and that could be because they simply couldn't find anything going that way, so they just have to go against the wind the whole time. So there's a lot that we don't know about those flights, but it certainly isn't something that somebody can say, this flight disproves flat Earth.
Yeah.
Not at all.
It's a straw man. And I make the same argument earlier about the Southern Stars. These are straw man because we are lacking information. And I really appreciate your research on this because, we're talking about upper atmosphere aeronautic science. These guys have been studying this stuff since 45. There's military industrial complex is really the people who make our airplanes, Boeing, So I think that they have a better understanding or like a different understanding than what they may be projecting, because they keep information. So it makes a lot of sense that they'd be hitting these streams. And you also heard about that balloon project, right? Project Loon?
Right.
Okay, so yeah, they put these balloons up there and they keep them at a certain level, and if they want to move them around, they descend them into the jet stream or one of these, airstreams, and they move it to where they want and they lift it back out. It's very likely that that's already going on to a large level.
Indeed.
So it's interesting. It's really interesting, Jerry.
Yeah, definitely. And it doesn't ever make much sense to me either in regards to a globe. Every time I look at this, it just doesn't match. I don't even know how the globe believers try and explain the jet streams because they can't be a result of the spin. That would be against their beliefs, right?
Right.
Wait, do they claim
Because
that?
the atmosphere is supposedly velcroed to the face of the Earth. So, in other words, the atmosphere is argued to be in sync with the frame of reference with the ground beneath it. And the reason that this argument comes into manifestation is because, for example, if you take off from New York going west to LA, you should technically be racing towards LA, while LA is racing towards you at about, say, 700 miles an hour. So a westbound, due to the spinning, hypothetically spinning Earth, that should be a relatively short flight, regardless of the jet stream. And you could get that, it looks like as a boost, if I was looking at that right. But either way, the spin of the Earth is far more allegedly faster than any jet stream. However, the return flight coming from LA going back to New York, oftentimes the flights are identical, but what's really bizarre is there's in many cases the return flight going east, with the spin of the Earth, is actually faster than the westbound flight, which is exactly the opposite of what you'd expect if the Earth and everything was spinning east.
This kind of shows you why right here, right? I mean, here's your jet streams coming across the United States.
It makes no sense when you look at it with a ball, but when you put it to an azimuthal map, it like makes complete sense.
I mean, this makes no sense at all, especially if the globe is spinning this way. Then you should have winds coming this way, not with the spin. And yet we don't even see any winds at all really going right to left here. Now, again, they're going to change with height, because if we go to 70 here or go to 10, then you get different speeds per height. But now you get a little bit moving this way here, which again, if you're going South America, could they just fly up here, fly down here, and follow this till they get to, down here? Again, you got definitely winds coming this way. I just don't know how they explain the winds on the globe model. Doesn't seem like
I don't think that the spin of the Earth has anything to do with any of the jet streams. From my understanding of the globe, they say that it, like he said, it's velcroed to the Earth, and it's funny enough, they treat it as a closed system, but apparently
it's not.
Spin. It's not. They treat it like a closed system. They say Coriolis is real, but then when you shoot a cannonball straight up, it falls right back down. It should be affected by this Coriolis. So I don't think and they say, wait, hurricanes are affected by the spin. So why aren't these jet streams affected? I mean, there's so many they want it both ways when you make the argument.
I had a commenter that I was, I wouldn't say arguing with, but I was just sort of baffled by. But just this commenter said the Earth couldn't be flat because we have winds. Winds wouldn't be possible on the flat Earth, and I'm like, wait a minute, winds? And I'm like, what do you think causes winds? And to me, the perfect explanation, it's very simple. You've got the sun heating up and disturbing
hot air, cold air
during the day.
Around.
Yeah, and then things cooling off at night. You get this flux in temperature, which is what creates weather patterns in any model. But it's people, for some reason, have married every single concept to be exclusive to a spinning sphere for some reason. And it's really, I mean, it is kind of ironic, but I mean, it really gets to the core of people's belief system that winds are exclusive to being on a spinning sphere.
Quick little funny story. The first time I presented this information to my younger brother, and I'm calling him out. Hopefully he's not listening to me. He doesn't watch this stuff. First time I presented this information to him, and I'm like, dude, look at it. It's interesting, this and that. And we were like 10 minutes in the call. He's like, okay, what about wind? That's completely... And I was like, what are you talking about? Wind? He goes, wind is caused by the spin of the Earth. And he was all angry and egotistical about it. And I was like, no, it's hot and cold columns of air moving up and down. What are you talking about? He's like, no, it's definitely caused by the spin of the Earth. I was like, dude, you got to learn about what you believe in before you can argue against it.
Really? Yeah.
But yeah, there's so many people who have these total. The other night, I was talking to some guy on the debates channel where he's a heliocentric kid and he's kind of trolling people. But he said, we were talking about the moon, and he goes, "How else does the moon get its phases? It's the shadow of the Earth, idiot."
I've heard that too.
And I was like, "No, it's the angle of light. In your model, it's the angle of light. No, it's the shadow of Earth." I said, "No, that would be an eclipse." Yeah. These people who they're defending something they don't even know about.
Yep. And that's it too. I mean, flat earthers know a hell of a lot more about the heliocentric model in general than ballers do, hands down.
Big time.
You have to. You have to really dig deep and try to understand what the heliocentric model is. And the more that you do that, the more you become a flat earther, because the heliocentric model is just, it's absolutely absurd. I mean, honestly, Everything just makes perfect sense when you consider the Earth to be, stationary, a plane, and all experiment, measurement, observation, testing, physical experiments, everything you can possibly do to prove one way or another what are we sitting on, and every bit of the evidence shows it's a stationary plane. And yet people will laugh at you and call you stupid because they believe that they are living stuck to the side of a spinning sphere in the void of infinite space.
My approach usually is philosophically, and I'll talk to somebody who hasn't heard this before, and I said, do you know the difference between primary and secondary knowledge? And what the difference is: primary knowledge is what you can gain yourself. Secondary knowledge is, from something else or someone else. I said, go back to your primary knowledge for a moment. Whatever you're doing right now, you're sitting on a stationary Earth. You sense no motion. You see no motion. The sun, moon, and stars are moving overhead, objectively, and you only experience level when you look over horizons and pretty much any altitude you can get to as a civilian. I said, what has convinced you? What secondary knowledge has convinced you that it's quite the opposite, that it's really you moving and those things stationary? I haven't been able to get a single good answer from that. And when you put somebody, and you won't, because that's what our primary knowledge, and this is why I think the words flat earth trigger so many people, because every human being knows they're walking on a level plane. Everyone knows the sun, moon, and stars move overhead. But because of the education and because of what the modern idea of this is, they've buried it deep down, deep down inside, and they don't ever acknowledge their own senses. And then when you tell them about it, there's something in them that triggers, and because they know they've only experienced those things. So it's interesting. I mean, the topic is I really think more people need to look into it. Honestly, that's my conclusion about this, because I've learned so much in the past year. The past 10 years combined doesn't even reach what I've learned in the past year. So
I totally agree. Yeah. And you know what? If we had some of the people who were in these, different sectors that are, 100 times smarter than I am, somebody who understands plane flights, somebody who understands, the little nuances that we don't quite get. I mean, I'm looking for somebody who does video, forensics to look into some of this NASA spacewalk footage. Now, no one's going to do it just because everyone assumes, why would NASA be lying? It doesn't make any sense. How would they have lied this long? Think of how many people would have to be involved in the lie, that whole line. And so nobody's looking at it. But if we had those people who have specialized skills looking into this, I'm sure that it would all be solved very quickly. And that's why I keep going back to the thing that pisses me off more than anything when John's talking about, hey, we need to go down to Antarctica and all that stuff. I mean, yeah, we do, but at the same time, they already know the answer. So why are we having to be forced? We already gave them money to find the answer for everyone. I mean, everything that NASA's ever done has been funded by us. So it shouldn't be, oh, we need to go down now and do this, this, and this, because we already all paid to have it done. And they obviously have rockets that can go up there. They obviously can go a certain height. And like you said, they know so much more about that. I mean, if they know anything, it's probably all the winds, exactly what's going on between 20,000 and 60,000 feet. They know that. And so it just pisses me off, because it's like, let's get somebody who can head NASA that, isn't an ex-astronaut, that isn't somebody who's there appointed as another government official. Trump's out there saying that, all these politicians are corrupt and they've all been paid off by special interests. But you watch, when he names the new NASA administrator, it's going to be some guy with political ties. Guarantee it. It won't be.
He's going to make Giuliani. He's going to put Rudy Giuliani as NASA lead. Some shit. Oh, it's crazy. Oh, my. But I agree with you. Once you get, Bill Hicks said it right. Like, he goes, I really think that when, someone becomes president, they take you into this smoky room with a bunch of capitalists and industrialists smoking cigars, and they sit you down, and a screen comes down, and it says, roll the film. And it's a shot of JFK assassination from a different angle, kind of from the grassy knoll. And it goes back up, and they say, any questions? Just what my agenda is.
Yep. That is, I agree with that. That's so true.
If they're willing to do that in broad daylight with such a beloved president, like I wasn't born yet, you know what I mean? Like this is history for me, but you know, they did this in broad daylight. If people didn't think that this was a coup, then I don't know what to tell you. If they think it's just some lone nut job who was an FBI agent, by the way, it's absolutely insane. Like I really think that was the point.
My research has led me to the conclusion that George Bush Sr.,
Yes,
George
sir.
Bush one was
He was one of the
definitely
triggermen. He was one of the triggermen.
involved in that, and JFK was the last president to
Yes, sir.
speak up and say that he was going to get rid of the Federal Reserve Bank and the CIA, just for starters. And so Donald Trump has never mentioned anything about that. So yeah, I think he's just going to be more of the same that we've seen. It's not gonna change much. I don't expect it to change much with any president unless they're talking about what JFK was talking about. And of course, we saw where that got him. So
yeah, I think that was a coup, though. I think that. I mean, think about it. We brought in 1,800 SS officers and powerful military men and scientists, like the best and the brightest of Germany. When we did the Nuremberg trials, only 24 people got prosecuted. A lot of people don't know that, but only 24 people got prosecuted. So we took all of these people, and for 10 years, we did not tell anyone. It was a complete secret, and we kept filling them into every part of the military-industrial complex in our military. Well, doesn't it seem like a perfect opportunity for a defeated country who has, love for their country? And even though they got brought into America, it seems like they would have a perfect opportunity to have a coup. You know what I mean? Like they're in powerful positions. They've integrated with the society. I don't know. I think about it sometimes that way.
The thing is, though, is the U.S. and Germany were really great allies prior to World War II, and you've got the Bush family who has a history with Prescott Bush that was, he was dealing with the Nazis even through World War II, trading with the enemy. He violated the Trading with the Enemy Act, so you definitely have those connections, right up to this present day. To where it's almost as if the old saying, "The world is a stage," or nothing that happens in this world it doesn't have some sort of a political causality, or at least a political manipulation of, because it really does. I mean, you just look through history and you'll find that there does appear to be some sort of hidden hand with an agenda, and you'll see echoes of it with the writings of people like Albert Pike, who predicted World War I, II, and III, which were pretty much, we're
on the edge.
I think we've been living through World War III for the last 10 years. Just nobody's actually gone on TV and said it yet.
I agree.
But technically, there's so much conflict throughout the world constantly. I mean, I don't know what else you could call it unless I suppose Russia and or China gets involved. So anyway,
I just get the impression sometimes that this might be the Fourth Reich, that they just merged power and moved forward. Like I've thought about that too, because I mean, people don't question what happened with these wars, in that regard. We just accept history as it's being presented. But something happened, something definitely happened in the course of this country. We're at a point that's actually pretty ridiculous. So I don't know. Maybe they'll audit the Fed. Maybe they'll. We can only hope, but I don't know. I think they're tightening it down.
And when you look at just some of these flights, look at how often they lose GPS signal. It's every time they get away from the land. The plane has no problem being tracked here, but then this dotted black line, if you move this little thing ahead, you'll see it just skips right by there as if it never happened. It's just because they lose connectivity. So then it picks up here as it gets closer to land. It'll fly over this land and picks up here. But I'll have people arguing with me saying that doesn't happen, that you can tell that none of the flights lose. They do. They all lose GPS, and that's why, to me, it makes sense what happened with MH370, same kind of deal. That plane took off and kind of was over in this region somewhere, and they had no idea where it is. And so, where did it crash? Probably somewhere out in here and in the water, and they have no idea because they weren't tracking it once it got away from the land. And that's the one thing they can't tell anybody is that, oh, well, we don't track planes in the south because there's no way for us to track them. It gets questionable, though, because I know people have asked, well, what about balloons? Isn't there balloons up in this region that would be able to track those flights? Well, obviously not, because we can see that there is no real tracking of the southern flights. I mean, you can see any plane going across the north. If we go up here, see here. So
well, there may be, Jaron, but they're not necessarily in the public domain. They may be able to track them. In fact, they likely can track them, but it's certainly not going to be in the public domain.
Yeah,
So
NOAA has a ton of this type of technology, technically.
I mean, if let's say that they could track them, then why wouldn't you show these planes traveling here today? Because then it would get people not to question why there's no southern tracking. So if they could track them, why not put them in this public domain? If you're going to put, let it reset. These planes are being tracked crossing. This plane's out in the middle of nowhere.
I think that's a really good question, Jaron. But the thing is obviously they're hiding something. What would it be? I don't know. But we certainly would have the technology to be able to do that in the south. You would think.
Especially if satellites are supposed to be real.
Well, yeah, but even if they're not real, I mean, and satellites are actually balloons, which I tend to think they are, or some sort of high-flying aircraft, whatever, that are continuously in flight. I just there's got to be something else there that they're concealing. That's the only thing I can think of.
Yeah, me too. And I've seen other ideas and other thoughts that there's islands out here, or who knows. Something I'm noticing: do private jets fly usually a lot higher than commercial?
Yes.
Okay.
No, not commercial. No, I'm sorry. No, not the commercial. The private jets probably fly maybe around that same height, but honestly, I've never flown a private jet.
Like 43,000, 45,000, 47,000, moving at 571. That's crazy.
Yeah, well, and it may be that they do, but honestly, I've never flown anything but a prop, and you don't really go much beyond several thousand feet, 4,000 or 5,000 feet above the ground level typically in a prop. So, that may be. So who knows? I'm sure we can find out.
Plus, I see a lot of them say blocked. Once I filtered it to just be above 42,000 feet, but I'm seeing all the planes are blocked, which is weird.
Interesting. Yeah, that is weird. Well, as always, Jaron, you impress the hell out of me with your research.
Yeah, good research, dude.
Just keeps my head spinning.
Yeah.
Right.
All right, everybody. Well, we're going to call that a wrap, and thank you so much for joining us. We will be back next week, and I will go ahead and continue on with what I was going to explain today, and we will move forward from there. So until then, be good to each other. Don't lie to each other. Open your mind. There is truth inside. Peace out, everybody.
Peace.
Take care.